Hello, my name is Jacob McGraw. I am the Nuclear Renewable Hybrid Operations Manager. I'm here presenting with Kang Tran, the Artificial Intelligence and Robotics Manager, and Saket Mitrani, the Nuclear Hardware and Software Restorations Manager. The name of our presentation is Providing Nuclear Solutions to California's Energy Problems, and we are presenting on behalf of our company, California Going Nuclear. The purpose of this presentation is to explain how and why our company should make nuclear power California's energy future. We will do this by initiating a nuclear renewable hybrid grid system, renovating our old plant in terms of their hardware and software, and installing artificial intelligence and robotics in all of our plants. The main goal of this presentation is to show that by doing the design set forth in this proposal, we have the opportunity to make California an energy beacon for the world to follow. All right, and with that, I'm going to hand it off to my friend Kang Tran to talk about how we're going to use artificial intelligence and robotics in our plants.
People prejudice nuclear power always comes with a nuclear disaster. The main reason for the nuclear disaster does not come from the failure of the equipment, but it comes from human error. To minimize human error as much as possible, California Go Nuclear will apply the AI system into the control room. The AI system operates as a support for the operators, and it does not decide any nuclear power plant's operation. At the present, the control system of the nuclear power plant is functioned completely by the operators. When there is a breakdown, the operator must analyze the data, evaluate the situation, and manually determine the solution. This process can consume a lot of time. Moreover, the manual process comes with a possible percent of human error. A small judgment error can cause a big nuclear disaster. With the AI system, the efficiency of the process will be significantly improved. The AI system is divided into two systems, which are the main and the support system. When there is a breakdown, the main system will display the solution procedures on the main screen after analyzing all the collected data. Now, the operator can immediately start to act instead of manually investigating. Beside the main system, the support system will display the relevant information of the corresponding step on the smaller screens. The operator can have more options to consider and decide the best step solution. Another plus side of the AI system is that it is affordable. The AI system had a price between $6,000 to $300,000, and it is one-time purchase. The cost of the system already include the activities such as developing the software, installing, and repairing when the system goes down. Besides the positive side, the AI system has certain barriers. One of the barriers is the complexity of use. The nuclear power plant's operator can be confused about the display of the AI and how it is functioning, which creates more pressure when there is a breakdown. Therefore, California Go Nuclear will create an internship program so that the operator can be familiar with the AI. The program will last for 2 weeks, where the operator will expose, use, and solve the simulating situation through the AI system. To keep the nuclear power plant as safe as much as possible, the equipment needs to be frequently maintained and repaired. A specific part of the nuclear power plant that California Go Nuclear wants to focus on is the storage of the radioactive waste. Before going through any further treatment, the radioactive waste must be stored inside a stainless steel canister and cooled down in a spent fuel pool with a depth of 10 meters and for at least 5 years. Although the temperature of the pool is between 25 to 35 degrees Celsius, which is very safe for the diving worker to check and maintain the radioactive waste canister in the inside part of the pool, it is still very dangerous because the waste material have high radioactivity and they can heavily damage the health of the diver. To overcome that situation, California Go Nuclear will use robots with the AI system to replace the diver job. As you can see in the picture, the robots are designed in a rectangular shape with two propellers underneath to make them more convenient in moving underwater. The robot includes two lights, one camera, and one terrain sensor in the front. Around the body, robots are equipped with additional light and three cameras. The light and the cameras allow the operator to see 360 degrees of the surrounding of the robot. The sensor enables the robot to automatically recognize the shape and the structure of the surrounding environment. The top of the robot is the weathering system and the crack sensor system. The computer circuit and the electronic device are covered with plastic, which makes the robot is completely water resistant. The plastic covers are designed to open and close easily so that the electronic internal equipment can be repaired and replaced in case of problem. With a battery of 300 watts, the robot can operate for 10 hours without using the weathering system and for 5 hours with the use of the weathering system. The robots are designed with two operation modes, automatic mode with the AI system and the manually mode. In the automatic mode, the robot can check the radioactive waste canister and the inside part of the spent fuel pool by themselves. If a crack or a side breaking is found, the robot will send a signal and data to the control room. After achieving the permission, the robot conducts wet of the crack with high-quality wetting performance. In the manually mode, the operator can freely operate the robot. The camera and the light provide the operator with the best visibility in the depth water. The price of the robot is also affordable. It has the price from $50,000 to $80,000, and it can go up to $150,000 if more functions are installed. California Go Nuclear will experiment with 32 robots in the operation system. These robots will be monitored and analyzed for the efficiency. If they qualify the requirements and achieve high efficiency, California Go Nuclear will build more robots depending on the size of the nuclear power plant.
I'm here to talk about the reactor hardware and software. So, current reactor technology is actually really old in the US. The average age of an American reactor is about 38 years old, with the oldest current running reactor being produced in 1969. Nuclear reactors make up about 20% of US energy supply, with only 96 reactors currently, which is really, really efficient considering that with 1,700 power plants, natural gas only makes up about 38% of the US power supply. Reactor meltdown is the primary cause of public distrust in nuclear technology. And this is because reactor meltdown is what you hear about when you think about like Chernobyl and things. And basically, what happens is the reactor gets too hot due to too quickly moving reactions, and that essentially makes the reactor actually melt. And once it melts, all of the radioactive components inside of it start irradiating the places around it, and that's where you get like stuff like Chernobyl. You get the issues that we have in Japan, stuff like that. So let's talk about some recent developments in nuclear technology. So as we discussed before, disasters are kind of the reason why we view nuclear technology in such a negative light. And this has led to an increase in safety features, and that's been the primary place where improvements have been made to nuclear technology. Now, the side effect of this is that nuclear reactors are now actually more reliable than ever. As you can see in the graph, as time has gone on, the availability of nuclear reactors has drastically increased, peaking out at around 84%, which is a lot. That means that 84% of the time in a year, the nuclear reactor is on and running. Most improvements have been in simplifications, so things like moving around pipes to make them easier to reach, eliminating extra pipes that are not needed, making moving parts less needed. The biggest improvement to reactor design, however, has been in the pebble bed reactor design. And what this is instead of using the radioactive rods that normal reactors use, this uses little balls of nuclear fuel. And what this allows us to do is actually continuously move fuel throughout the system. And this allows us to both keep the reactor on for longer periods of time and also shut it off in the case of an emergency. Future designs that have been looked around at include updated cooling methods, but that's really the only thing that people have really looked at, which is just having cooling methods that are safer, are more reliable, because that's really where the issue is, right? Is reactor meltdown is an issue of heat. So if we have better cooling, then we have a better, safer reactor. Take a look at some hardware improvements that we can make. The primary issue, as we said, is the cooling system, and pebble bed reactors really help with this. What pebble bed reactors do is introduce what we call a passive cooling system, in which if the reactor gets too hot, the rate of reaction actually reduces, and due to that, the reactor cools back down a little bit, and it keeps it in like this feedback loop of just keeping it in a consistent temperature. Now, even with that, we want to make sure that there's absolutely no chance that the reactor can melt down. So we've installed a simple fail-safe system consisting of one part melting if the temperature inside of the reactor gets too hot. And this part is the release for the fuel once it gets used. So the bottom of the diagram that you see here, that part will just melt and remove all of the fuel from the reactor in case it gets too hot. This ensures that the reactor will never melt down, because this is kind of an inherent property of the material. There's no mechanical aspect to it that can go wrong. We will also install a highly serviceable system that allows easy access to frequently replaced parts, such as pipes or vents or things like that, where it wears down quickly and you need to replace it often. Those things will be able to be replaced quicker, and this allows us to also make it safer due to the fact that if something needs to be replaced in an emergency, that can be done really quickly. More reliable cooling system with fewer moving parts is also essential, because the cooling system, like we said again, is the primary issue. So having a cooling system that's more passive and requires less moving parts allows us to have a safer system that we can rely on better. Let's talk about some software improvements. Now, the primary issue with software is actually its lack of shelf life. And this is due to the fact that software needs to constantly adapt to new regulations that are set forth by governments, and these government regulations are always changing. And so, as these regulations change, you need to change the software as well, and as a result, software gets obsolete really quickly. Now, a switch to qualitative data is going to improve reliability of the software by essentially taking into account previous experiences of the plant, and taking that into account rather than just using, say, the number for how long a part is going to last. Additionally, data analysis capabilities will be improved through the use of AI, which will be able to further analyze these qualitative data aspects and provide an individualized system for each plant. So even though our data or our software is going to be the same software, it's going to be individualized over time due to the AI system. The AI system, being an AI system, can also adapt to new standards, and this is really important due to the fact that, as we said, standards can be constantly changing. So having an AI system that can constantly change will allow us to have a software that lasts pretty much the entire lifespan of the plant itself. Now on to you, Jacob.
Thank you, Socket. Okay, so my presentation is going to explain how and why California should combine nuclear energy and renewable power. First, I'm going to explain what California can expect in terms of energy. Like, is this a model that's going to give California a lot of energy? Next, I'm going to talk about how this model will affect California in terms of grid stability. Is this something that's stable, and can we sustain this going forward? Next, I'm going to talk about mass integrations with IoT technologies. Specifically, I want to talk about the reactor coolant inventory control, the boiler operations, and probably most importantly, how our company will integrate our plans with local wind and solar farms. Okay, so when I say I want to make California a zero emission state in terms of energy generation, it's obviously a very difficult goal. Some may even call it impossible. And it's true that by our estimations, it's going to take several decades and nearly $40 billion to make this dream a reality. But it's way more practical and doable than many people may realize. Okay, so you see, nuclear power is really powerful and consistent, but it's very expensive. A renewable system is very powerful and very cheap, but is inconsistent. A nuclear renewable system will account for the weaknesses of both options and combine the only two energy generation methods that don't harm the environment during normal operations. Additionally, a study by the nuclear experts Gabar and Abdusami showed that a nuclear system is more environmentally friendly, cost effective, and provides more power to the grid than any previous model. Also, when we combine this with the designs that I'm going to talk about further in this presentation, the energy generation is going to be even more than any previous model has basically ever even thought of. Okay, so at this point, I'm pretty sure we all know that climate change is one of the most serious problems facing humanity at the moment. But is this a problem that can be solved? And if so, how do we solve it? Well, at this point, we pretty much know that the best way to fight climate change is to pursue renewable energy sources that don't damage the environment. But there is a problem with these energy sources. Thankfully, this problem has been given both a name and a handy graph, which I'm going to show right here. This problem is called the duck curve, and it basically represents California's inability to meet energy demands using only solar power. Okay, so from 3 a.m. to 3 p.m., there's generally a steady, smooth supply of solar power that can meet energy demands pretty comfortably. But after 6, what happens is the sun starts to go down, but California's energy demands stay the same. After 6 p.m., we all don't go down with the sun. We're still up doing things, living our lives, doing whatever. And the end result is solar power not being able to meet energy demands throughout the day. And the end result of that is California needing to use more environmentally damaging methods to meet energy demands. In most cases, this is natural gas, as I'm going to talk about later in more detail. And while natural gas is better than other fossil fuels, it's not that much better. And really, California needs to switch away from it as much as possible in the coming years. So our company is going to fix this problem by combining the inconsistency and cheapness of renewable energy with the abundance and power of nuclear energy. And I'm going to explain how our company will do this in more detail right now. So when I put forth a proposal with the goal of changing California's whole energy profile, the question is, what does California's energy profile look like? More importantly, how do we change it? So in terms of what it looks like, basically what it looks like is natural gas. Natural gas makes up 30% of California's energy profile, and the only other energy source that comes close is residential transportation, coming in at about 20%. While natural gas is a good fuel source and is better compared to other fossil fuels, it still damages the environment way more than we want, and California should phase it out going forward. So how do we phase it out? What exactly do I want to do? In layman's terms, what I want to do is make renewable power California's main energy source while basically using nuclear energy as sort of a stopgap during peak load regulations. So what I'm going to do is I'm going to put 4 power plants in California's most energy intensive regions. And this is going to be fairly like space savvy because, as Sokka pointed out, we're not using any new land to build these plants. We're just using an existing infrastructure that already exists. So what I'm going to do is I'm going to put one plant in Las Vegas, two plants in Santa Clara, and one plant in Los Angeles. And additionally, when I combine it with the other optimization methods that I'm going to talk about further, like the power generation that we get is going to be even more than what previous models suggested that it would be. So how do I even know that these designs are going to work? I'm asking for a huge amount of money to do this after all. And what I have in the form of proof are two tables that I've gathered from Homer simulation data. That's Homer, which stands for Hybrid Optimization Model for Electric Renewable, HOMER. And I'm going to explain what everything here means step by step and case by case. So case 1 refers to a fossil fuel-based model. Case 2 refers to a renewable-based model. Case 3 is fossil fuels and renewable energy. Case 4 is nuclear energy and renewable energy. Case 5 is nuclear energy exclusively. And the data here is interesting for a number of reasons. And first, I'm just going to point out the table on the left refers to greenhouse gas emissions, and the table on the right is greenhouse gas emissions. The table on the left is the costs, both initial and operating costs of the facility. And we see here a couple of interesting results. First, renewable energy is pretty damaging, especially compared to nuclear and nuclear renewable. The reason for this goes back to the duck curve, which I mentioned earlier, because renewable energy just can't meet the demands of the citizens long term. So you have to use fossil fuels in those peak load regulation times in order for the citizens to have power. And next, we see that a renewable fossil fuel system is so environmentally damaging, you might as well just use fossil fuels outright. So California's current method of natural gas and renewable energy just can't work in the long term. Next, we see that while nuclear renewable and nuclear exclusive have fairly equitable costs, we see that we'd have to build more nuclear plants in order to meet those demands in the long term, which of course would increase the cost dramatically over nuclear renewable. Additionally, because of these extra plants that we'd have to build, there would be way more nuclear waste lying around, and nuclear waste cleanup is expensive, difficult, and most importantly, environmentally damaging. And then every other energy generation that we see has so many flaws that they really aren't even worth considering. Probably the most important aspect of this design is the stability it will bring to California's grid. As California shifts more and more towards renewable energy, there will be more and more variation within the electrical structure. A study performed by the nuclear experts Gabar and Abdusami revealed that a nuclear renewable hybrid system yields an extra 16 million kilowatt hours to the grid annually. This yields an excess grid stability for California as there's more energy floating around within California's energy structure. And of course, this energy isn't just given away. This is energy that the power plant sells to the state of California, which means more profits for our clients. However, there is a problem because current models modeling the energy structure of these plants use probability instead of hard data. This is because it's hard to know how much the sun will shine on any given day, just because of how many variables there are. Probability models work wonders in the short term, but long term, there's more and more variation depending on how far out the models go. Our company will fix this by providing hard data by integrating our power plants directly with these wind and solar farms, as I will describe in great detail in just the next section. And then supplying the power to the grid in accordance will yield a great amount of grid stability because we won't just be guessing based on these models. We'll be doing it in real time in accordance based on the sun levels that are happening at that moment. Additionally, our company will streamline these power plants by streamlining the boiler optimum efficiency level. So the same study performed by these experts yielded that these plants are actually so efficient that they make the boiler basically not needed in the overall grand scheme of things. Our plants will improve on this, however, by using the boiler's already existing infrastructure to provide heating to the establishment, and this will reduce the heating costs and make the workers that are still in the plant happy. Okay, and also this will increase grid stability even further when we go into the cooling section that I will describe further in the next section as well. The main way I want to innovate Californian power plants is to have a mass integration with IoT technologies. IoT refers to the Internet of Things, and it is the physical linking of devices using the Internet. As previously mentioned, probability models are currently used in simulations to model the variation of wind and solar. And as time goes on, these models will become more and more inaccurate. Our company will fix this by installing sensors directly onto these farms, with the goal of having data being sent to these farms in real time to eliminate any variance that could possibly exist. Additionally, nuclear experts have determined that the more variation there is within the power structure, the less energy that is generated from both power sources. Therefore, eliminating this variance will increase the efficiency of both power forces tenfold. Okay, so first I'm going to talk about solar farms. Solar energy is the most important renewable energy source that there is. And this makes sense if you think about it. The sun is substantially larger than the Earth. So what power source on the Earth could rival the sun? Our company will harness this energy by installing handheld sensors that can be installed directly on the sides of solar panels. Rather than capturing the sun's data, our devices will simply transmit the data back to our plants so we can transmit power to the grid in accordance with this energy. This design will save on research and development costs and make installation of the sensors much easier. Additionally, because of the handheld nature of these sensors, we will be able to install these sensors on a solar panel in a matter of minutes, probably without even disrupting regular maintenance. Additionally, because any solar panel on a solar farm would accrue the same energy, we would only need to install one sensor on any given individual solar farm, greatly increasing the number of solar farms that we can potentially integrate into our plant's energy structure. Next, I'm going to talk about wind farms. Wind is also a really important energy source because there are places in the world where the wind is blowing at a constant and high level, providing a constant, renewable green energy source. Also, it should be noted that while this illustration shows a sensor being installed on the outside of a wind farm, a sensor could easily be installed on the inside as well. Now, the thing about windmills is that they need regular and constant maintenance in order to operate safely. Therefore, it would be little trouble at all for a maintenance worker to install this on a windmill without disrupting maintenance in the slightest. Additionally, our sensors will be based on a gyroscopic design, meaning that they sense movement to a really accurate level. This gyroscopic nature will ensure that our sensors can be installed anywhere on the wind farm without and work just well. Additionally, much like our solar farms, only one sensor would need to be installed on any given wind farm because, of course, any windmills on the same wind farm would accrue the same energy. The next way that IoT will benefit our power plants is through the use of the reactor coolant inventory control. The reactor coolant inventory control is exactly what its name implies. It's a system of valves and releases that releases coolant to different parts of the plant in accordance with where the plant happens to be overheating at that time. However, this system of valves and releases is pressure-based and therefore is outdated and costly. This design could vastly be improved with IoT sensors that would improve efficiency and actually be able to sense malfunctions before they occur. Therefore, our plant's artificial intelligence and robotics could actually perform preventative maintenance, leading to a safer and more efficient power plant. Okay, so next I'm going to hand it off to Kang to provide a conclusion and recommendations for further action to make California green.
In conclusion, shifting to renewable energy source is one of the greatest challenges in the modern history. California will need to undergo a radical change in the way it accrues energy to fight climate change effectively. Our company will enact a series of changes that will make California substantially greener. California Go Nuclear will design and construct 4 nuclear power plants centered at California's most energy-intensive area. Also, our company will install artificial intelligence systems into California's atomic facilities. California Go Nuclear will virtually eliminate human error by using robotic workers to run day-to-day operation and artificial intelligence to run more difficult tasks. Additionally, our company will renovate our power plant hardware and software. California Go Nuclear will improve reactor software by implementing qualitative data into our process models. With the revolution, California's energy model will be an example for the world to follow. Thank you for listening. Please ask if you have any question.